Good evening, everyone. Welcome to another Netguru Hangout mobile event. I'm excited to say that today we'll learn some cool stuff together. But first things first, what is this whole Netguru Hangout mobile? This is a series of online events focused on mobile technology enthusiasts. In upcoming live events, we'll cover topics related to iOS, Android, React Native, and Flutter. Each event focuses on one of these technologies. So today it's time for Android. Plan for today is really simple. We'll have a presentation, and after the presentation, we'll have a discussion and Q&A. I encourage you to ask questions during the presentation, and we'll take care of them during the Q&A and discussion part. Okay, so now you know what is Netguru Hangout and what will be the plan for today. Now let me introduce our great speaker. Gabriel is a senior Android developer and Android team leader. He is passionate about his work and new technologies, and also a big fan of science fiction and fantasy. In his free time, he tries to play guitar and have fun reading books. Okay, so Gabriel will tell us today more about annotation processors and why we need them in our projects. And also, what is, I think, the most important thing here, we'll learn how to write our own annotation processor. So, without further ado, Gabs, the stage is yours.
Hi, thanks, Szymon, for a nice introduction. Hello, everyone. Greetings from Woods. It's nice to be here. It's a real pleasure. So, yeah. My name is Gabriel. As Szymon said, I'm a senior Android developer and Android team leader here at Netguru. And today I would like to tell you a bit more about annotation processors. But first, let me tell you why this topic. I just some time ago wondered how we can take benefit of annotations of processors, how we can reduce the boilerplate we have in our applications. And I thought that, why not to try to create my own annotation processor? It's a really interesting topic because those annotation processors are widely used. And maybe some of you will say, nope, I have never used it before. To be honest, I really doubt it, mostly because it's commonly used in very large set of extremely popular libraries. Let's name a few. For example, Dagger is using code generation and annotation processing for generating the whole dependency graph. Thanks to it, you don't have maintain the graph by yourself. You don't need to have I don't know, many lists of generic types, etc. It's all done by code generation. For example, Room handles all the database transactions, all database boilerplate for you. You need just to write some class and annotate your methods with proper annotations. How cool is that, right? Butterknife binds view. If you remember it, of course, because Butterknife was used commonly in Java projects. Data binding, well, it just binds your data, right? It's all using the annotation processors. And you might ask why? Because it reduces boilerplate. Imagine writing the whole operation on database by yourself. It's just a matter of annotation right now. You just annotate your method with query, and you don't have to worry about it. It improves runtime performance because everything is handled in the compile time, of course. That also ensures compile time safety. For example, imagine the situation in which Dagger or Room is compiling completely fine, but there is some kind of issue when the user clicks the button and then, for example, Room starts to verify your query and crashes your app. It will be something really painful. So you have this safety when it comes to compile time. If something is wrong in your dependency graph in Dagger, you will know it in the compile time, which is super neat feature. And the last but not least, it's really fun. It's like creating software that creates software. It's just awesome, just like some kind of new level of programming, right? But yeah, let me start from the beginning, and let me talk me a bit about annotations itself. What are annotations exactly? Why we need them? What was the reason they were introduced? And I won't believe you once again if you would say you never used it before, because there are really many of them, like serializable, like module, which indicates that this module will be maintained by Dagger, or provides, which tells what exactly method will do. Inject requires API, suppress warning, deprecated, or get from retrofit. I bet you know almost all of them, right? Because annotation is something so common that you see them everywhere, almost everywhere. But what are exactly these annotations? Let's see this example for get from the retrofit method, right? If you would go inside this annotation, you would notice that like nothing is in there. There is no logic responsible for like calling your API or something. It's some kind of information only, basically. So you're looking at your method, you know that this method will invoke get method on API/memes endpoint, right? It's just plain information which can be used either in runtime by runtime annotation processor, or compile time annotation processor. So we have two ways of getting usage of these annotations, right? And it's really worth to mention that those annotations were, almost all annotations, of course, were introduced in Java 1.5. So it's not something that is completely brand new, but it's either something that that was since the beginning. Before that, before the annotations, we will have to make everything almost by ourselves, right? And I mentioned about this processing, this runtime processing and compile processing, and I will focus in this presentation on compile time processing. And since this time, every time I will say annotation processor, I will mean this compile time. But of course, let me introduce you to the world of annotation processing, what's going on inside of them. And I have a small diagram for you, how annotation processor works. It basically, and I will mention it once again, it works in the compile time. So during the compilation, we are scanning for the files that are yet unprocessed and contains some annotations. If compiler will find any processor that can handle this annotation, it will pass this class, this method to annotation processor to be handled. And after that, it will perform another round of scanning. So as you see, it's something like a loop. So we are looping through the files, we are processing them, and this process will end only if all files are processed by annotation processor and then compiled. So this is the main reason why your project probably shouldn't have many of annotation processors, because it has impact on the compile time. There is also a very big danger in that, because as you see, if it's working in rounds, there is possibility that you will have a processor of annotation that will create or generate the code, which will contain another annotation that will need to be handled by another processor. So there is a possibility to have this infinite loop, which is really dangerous, because basically that means your application won't even compile. That's something you need to take care of, to be sure that you are not doing anything like that. It can be also dangerous, because imagine the situation in which your processor will generate the code, but not in the new file, but in the existing one. This can lead to very dangerous situation in which the whole file will be scanned enormous times. That means that compilation will take almost forever. So that's why there is introduced one major rule in the code generation process. Annotation processor can only be used to generate new files and not to change existing ones. And this is the main rule, and this is the main constraint of annotation processor. You should be aware, because it's applied to all of annotation processors. I mean, almost all annotation processor. There's one exception, which is Lombok. Lombok is a annotation processor. It's a library used in Java, which meant to be something that reduced boilerplate connected with creating getters, setters to string, etc. So basically, it was doing exactly the same thing that the data class is doing in Kotlin. Lombok was able to modify existing files, but it was like really avoiding annotation processor limitation only because it has a compiler plugin, and this plugin was responsible for, like, let's say, merging those files into one, right? For the sake of this presentation, let's assume that we have this limitation. We won't create any compiler plugin. We want to create a just annotation processor, and this will be main part of our presentation, of course. So let's create a simple annotation processor, which will generate class with one method returning a simple value, right? For this, we will need two things: an annotation and processor, obviously, right? What we can do is basically break those responsibilities, those things, to separate modules, right? Let's call them my library and my pros. Let's be a professional in that. I bet that you saw many times this approach when you have library which you use like implementation something and key apt something /prods, for example, or compiler, right? Let's assume that we are gonna do this in a similar manner. But first thing first, and we will need to create our annotation that we will process a bit later, right? So in my library module, let's create generate presentation title annotation. How we gonna do that? It's rather simple thing. In Kotlin, we have this keyword annotation class, so it's pretty straightforward. But what's a bit more complicated, I would say, is that we need to annotate our class with our annotation with another annotation. Yeah, that sounds scary, but it's really not. So yeah, this target annotation, it's an annotation that indicates to which element we can apply our annotation. We can have the class, we can have constructor, we can have field, I don't know, method, or even another annotation. For this, for generate presentation title annotation, I've chosen that we will use it only for the class. So when we will try to, for example, add this annotation to the field, we will get compilation error, because compiler will take care of handling that case for us. The next, a bit harder annotation which we need to have is the retention annotation. And retention is the way in which our annotation will be stored in the output of the file after compilation, let's say. We have three choices. The first one is the source. The source means that annotation won't be stored in binary output. So we can assume that compiler will just basically delete this annotation after compiling class in which this annotation is used, right? The second one is binary. That means that annotation will be stored in binary output, but we won't have access to that in runtime. So when the application is executing, we won't have any possibility to check if, for example, class is annotated with our annotation. And the second one is runtime, which does exactly what it seems to be doing. That means this annotation is stored in the binary output and is also visible for reflection. So we will be able to process them in the fly, let's say. For my annotation, I've used target class, so we will be able to use this annotation only on the top level on the class, and it won't be available in binary output, so it won't be available through via reflection, which perfectly makes sense for me because I want to have my annotation processor works in compile time. And it's basically this. Let's move to the myPros module, so the module in which annotation processor will be created. First of all, we need to add some dependencies. The first one, a very important one, but I will tell about it a bit later. The first one is auto service from Google, which will reduce boilerplate for us. And the second one is Kotlin Poet, which will make our life a bit easier when generating the code. Of course, we are using some annotation processor. You might notice this by using the key apt keyword here. So we are using annotation processor inside our annotation processor. It gets so fun. And compile only for our library, just to have this annotation visible in our module. Why not implementation? Because we don't need it after compilation, basically. So that's fine to have it as compile only, right? Okay, let's move to the heart of our project, of our annotation processor. And it is, of course, our myProcessor class. The first role of annotation processing is to be careful with our operations. We don't want to have significant impact on the compile time, right? But first thing first, let me tell you about what we need to handle in our annotation processor. The first step is to annotate it. Yeah, there are plenty of those annotations today. We need to annotate it as auto service. This coming from the library we declared dependency on the previous slide. It reduces a boilerplate which we would need to include in our build Gradle file to register our processor to the whole tree of existing annotation processor. Because, as you might remember, there are plenty of them, and they are working one by one and can communicate in somehow between each other. I mean, communicate because one processor can take impact on the other one by generating the class, which will be basically handled by another one. Yeah. Okay. So the next thing, the next annotation is supported source version, and I've added it only just to present to you that it's able to do this via this annotation, but I've also overridden the method getSupportSourceVersion, which does exactly the same. We are telling the compiler which version of Java will be supported. I've added this release 11 just to support the Java. You might choose whatever you like. You can use one of them. There's also this method getSupported annotation types, which is basically a set of strings. So we need to implicitly told the processor in which annotations we are interested in here, right? For this example, I just put here this generate presentation title annotation, only because I don't want to have impact on other ones. Of course, there are no limitation. You can have like here, I don't know, serializable annotation or inject annotation. That's fine, but you will have to process them somehow, probably. And if we are talking about processing, there is this process method, which is basically the main part of our annotation processor. So let's see how we can process our stuff. First of all, we need to be sure that we are working in KAPT Kotlin environment. So first, we need to check if our environment has these options to generate the file. If no, then probably means that we won't be able to generate the file anyway. So it's better to return from this method. And next, we are operating on run environment object. And you probably should remember that I said that annotation processor works in runs, right? This is the why and how it's reflected in the code. Please keep in mind that instance of your processor will be created just once, but process method can be invoked many times with different run environment instance. From that, you can obtain get elements annotated with our annotation, and based on that, generate file. So it's I would say it's pretty straightforward right now, but it will get a bit harder because now we will have to generate our file, our class, right? So let's dig inside generate file. To generate it, first of all, we need to have package name, right? And once again, we can obtain it from processing environment. Please keep in mind, if you would have annotation that has many target types, for example, class and method, right? You would need to handle this possibility here, because element can be really anything right there. You don't have guarantee that, for example, element here is class or element here will be method. You need to check it, but we have this. We can be sure because our annotation is annotated with target annotation, which specifies that we can use it only on the class level. So be aware of that because it can be source of future problems. So file name, I've chosen that I will just have prefix Netguru. Yeah. So our file name will be Netguru and the name of the original class annotated with our annotation. And next we are proceeding with class builder. And this is when Kotlin Poet came to the rescue. This whole syntax is based, of course, on Kotlin Poet. Thanks to that, we can avoid, I don't know, specifying the strings or using some kind of templates. It will be really error prone and painful, and I don't know how would we be able, to create more advanced classes or more advanced files without Kotlin Poet. So let's see what we are doing here. Firstly, we are specifying the fun spec builder. I'm assuming that we are gonna have the generate presentation title method inside. Adding the statement with returning the value, your own annotation processor in this case, and I'm indicating that this method will return string, and I'm just gonna build it, right? The next block of code is just some kind of boilerplate for building the file itself and writing to files. So nothing really interesting right now. So of course, this is, once again, I will say this is really basic example on how to generate a really simple class with one method without any parameters, without any complex structures. But please keep in mind, you are allowed to do this. Kotlin Poet supports constructors, supports methods with parameters, getters, setters, fields, companion objects, and many different things. Even you can write your own annotation to that file. So it's really powerful. There are many things that are possible, but they are a bit more complicated than the stuff I've done here. Okay, so after we created and generated our file, it's time to test them, right? How to do this? How to do that? Just like another library with KAPT, we need to add our dependencies, right? It's of course our application module, our app module. So we need to have this implementation, right? And that will create a possibility to take our generate presentation title annotation, and want to have KAPT on my pros, which will be responsible for adding annotation processor. Okay, let's make usage of that finally. So let's imagine we have class called Hangout, just plain class without any value, any fields, any methods, or any event constructor. Let's annotate this with generate presentation title, right? And what we are expecting to have here, of course, we want to generate the Netguru Hangout class, right? Because this is what our annotation processor should do. But if you are familiar with Dagger, you might remember how painful it could be when you are hitting this rebuild button and you are trying to type Dagger app component and there is no results, right? So this is the moment of truth. We are gonna hit the build or run application, and then we are able to access our newly created class. So let's validate if everything was implemented correctly. We have class which name is Netguru Hangout, so it's pretty correct. I wanted to have this prefix being included just before the original class method, so that's nice. We have one method called generate presentation title, which exactly what I wanted to have. It returns string with value your own annotation processor. So it looks like it works, right? It's exactly what we wanted to achieve. And just to show you that it's true, we can just use it in our activity class. That's because remember this environment option that we take. This was also a output file, a directory to the file. So we are able to access this class, right? To access this class from our application module. Of course, I know this example isn't pretty exhaustive. I would say I wanted to kinda interest you in the topic. I wanted you to get familiar with how annotation and annotation processor works. I hope you are curious about how it can be used. There are plenty use case for that. And I want really to encourage you to dig a bit deeper into the topic, and I can recommend you some sources. For example, it's really worth to go through source code of popular libraries that use, for example, that use annotation processing like Room or Dagger. Especially, I recommend Room. It's nice architected, pretty new stuff, I would say. It's really easy to read. You can take a lot of benefit of that, I would say. Dagger is another level of complexity, I would say. So it's good to take a look on that, but it's extremely complicated. The next thing is reflection. So this runtime processing of annotations, how reflection is working, what we can achieve, what are the limitations of that. Compare this compile time annotation processing with runtime annotation processing, and see what's the difference. And last but not least, and it's like another level of generating code and operating on existing sources, is compiler plugins. Who knows? Maybe you will be creator of the next Lombok plugin that will be able to modify existing files or create something extremely powerful with that. Of course, the whole source code of this presentation is also available on my GitHub. There is a QR code for that. And what can I say more? I really encourage you to download the code, to try to experiment, to see how Kotlin Poet is powerful, how many benefits you can have from implementing your own annotation processor. Let's see what libraries are taking advantages of annotation processing, and how it all works together. Thank you so much for your attentions. Hopefully I have interested you at least a bit in the topic. So feel free to ask questions, feel free to download the code, to comment on the repo, or just to ask questions in the comments. I will try to answer as much as I can. Thank you so much.
Okay, thank you, Gabriel, for this really great presentation. I really think it's full of good knowledge. Okay, so now we will get to some discussion and things. And I have a couple of questions. I also see that there are some from the audience, so we'll mix it somehow. So I have one question. You mentioned that annotations can be like the one that you showed us are the compile time annotations, and you mentioned also that we can do something on the runtime. Can you tell more about it?
Yeah, sure. I want to maybe have some example. Like I mentioned this retrofit, right? Retrofit is something is using this runtime processing because you don't have generated code basically. This is something that it's performing in the runtime via reflection, so it has some impact on the runtime. For example, JSON, another library which is working in similar manner, that has some impact on that, because in the runtime you need to scan the files which are already in memory, so it has some overhead of that, and it doesn't ensure I would say type safety. That's the most important difference, I believe. For example, if you are using the JSON, you are not sure that the model you are trying to parse will do it successfully, because JSON doesn't generate code for it. It's doing when application is basically running. So it's it can lead to, for example, crashes. I don't of course, saying that it's worse or inappropriate, I would say, approach. It's different. It has its benefits and disadvantages, like always, right?
Yeah, sure. Yeah, okay. So to sum up, when we want to have the runtime annotations, they has to use the reflection. Is it always like that?
Yeah. We can say like that. Mostly because those annotations are stored in binary, so it's I would say, packed into a binary file and then are analyzed on the fly. Yeah, and that's why we are using reflection. Yeah.
Okay, thanks. Okay, so maybe now one of the questions from our audience and from Mateusz Pachulski. I am missing a bit a real life example. Could you provide something?
Yeah.
Sorry, Gabriel. I'm just thinking about like when we can use it. I mean, of course, we have the Dagger, we have Room, we have like all those cool stuff, cool libraries that uses the annotation processors. But for the like developers in projects and products, how can we take advantage of it?
Yeah, sure. Thanks, Mateusz, for question. That's really on point. The first thing that came to my mind is, for example, we can utilize it to reduce boilerplates in repetitive places. For example, imagine you have like class which is supposed to be used in communication with network. So you have like, for example, user DTO, right? And you have your plain user data object, right? And in most cases, they are almost identical or with really I would say not much without so much difference. Sorry. So you can create some annotation processor that will generate mappers for you, for example. So we'll take one object, create a mapper via code generation, and map it to the another one. So you won't have to create mapper by yourself anymore. Of course, for the simple cases, right? The next case I saw that some annotation process could be used, for example, to creating the Navigator class. If you are not using navigation component, you can have this repetitive code which creates new intents for each activity, right? You can have annotation processor, for example, annotate your activity class with, I don't know, navigation, right? And it will create the whole logic responsible for creating the intent for you. That's whole lot of stuff that can be covered by annotation processor, but you need to be sure that it will make your life easier, not harder, because it's easy to create the annotation processor that will do so much stuff that you will stop control it over your application, right? So it's good to have this balance between creating annotation processor for everything to not creating annotation processor at all, right? Hopefully it answers your questions.
Okay, so to sum up, when you have some repetitive things, you can create an annotation processor, but you need to be aware that it cannot be too complex, right? To not make your life even harder.
Yeah. So a bit more, because if you will have some really harder things covered by annotation processor, right? You can have the situation in which you are trying to use it to the like something that should be written by you. I haven't mentioned it before, but code generation and annotation processor had really one drawback. It's really hard to test them. We are using this Kotlin pod. We are generating the files in the runtime, in the compile time. So it's really hard to test if our file will be generated properly. And it's really hard to test if we will cover every edge case which we want to cover, right? It's not so easy to develop annotation processor that makes our life just straightforward and easy, because it's really a big effort. But if you will save, for example, 5 minutes a day because you are not creating mappers by hand, maybe it's worth to have it, right?
Okay, so by the way, is there any alternative for Kotlin Poet?
To be honest, nothing that I'm aware of. I mean, Kotlin Poet is Kotlin Poet is a library which came from Java Poet, which is not so surprise. I assume. So Java Poet was the first. Then was Kotlin Poet. To be honest, I'm not aware of any other libraries like that. Maybe because it's not so popular topic. So not many creators are trying to create another library. But there is something I need to say. Using Kotlin Poet is crucial because imagine creating this whole class, remembering about imports, about the package name, about the file location, only basing on strings or some kind of templates. It will be extremely error prone. And adding to that the thing that you are not able to easily test that, it's like a disaster, right? So answering the question, I don't know any alternatives, but Kotlin Poet is a really good library.
Okay, so I also have another question from our audience. So it's from Kacper Wojciechowski. Did you try the limits, and when it starts to really affect build time?
No. To be honest, I haven't tried to set the limit, but I've made this infinite loop I was talking about just by mistake. So when I just created the annotation processor that was generating file with another annotation which was processed by another annotation processor. So it led to the fact that it won't even compile. I haven't do any benchmarks, mainly because there are plenty of it in the internet. To be honest, you can just Google like Dagger compile time, impact on compile time, or room, right? There are plenty of benchmarks. There are plenty of this kind of comparisons between using the, for example, Coin, which is based on the runtime processing, and Dagger based on compile time processing, right? So you can have this data, but I haven't performed this on my own. But I will assure you that if you are gonna create some simple annotation processor like this, I presented here, this compile time overhead won't be noticeable.
Okay, so it's a nice. I think it's in general very nice tool. I'm also thinking about one devil thing. Is it possible for one annotation to inherit from another? Like, can we somehow do it?
Not really in terms we know from the objective object-oriented programming, because when you are extending some class, you expect to have a special operator, for example, for that, like in Kotlin, or extends in Java. In annotation, it's not possible, but let me make this clear. You can annotate your annotation, and it propagates, I would say. So if you have your annotation marked as, for example, deprecate, that means that every class that will use your annotation will have deprecated annotation as well. So they are kind of accumulating, right?
Okay.
So annotation which has annotation propagates them to the caller, I would say. But there is no such thing like extending a notification.
Okay, so no inheritance, but like you said, it's like merging or something.
Yeah, exactly. It's like merging one, so which can be really useful, because as I showed you on the slides, I was using this annotation target and retention, right, to create my own, and thanks to that, compiler knows that my annotation should be used only to the target, to the specified target, right? So to the class. That's because those annotation is propagated as well. So so compiler is like taking care of it.
Okay, so this tool is really it has a lot of power, and I'm just wondering because it was introduced like you said in Java 1.5.
Yeah.
And from the historical point of view, was there anything before it?
Not in you were able to achieve some results like that, but not in such a way. I would say you will you have to create a compiler plugin or have it based on build system, so you can you could write some example Gradle scripts invoked in the proper time. I think that there was Ant back then, not Gradle, but doesn't matter. So yeah, you could do this in like more classic way, I would say. But before annotations, we were using another classes, empty classes. I don't know if you remember, maybe you do. There was this case when serializable was just interface. If you would have to if you need to have your object serializable, you had to implement the interface which doesn't have any methods. That's because in the runtime you were able to tell if this class is basically extending serializable, so it can be serialized by some kind of tool. So this is, as I mentioned, it's not a new stuff, I would say, but it's it wasn't there since the beginning. So there were some workarounds, and I think that's the main reason that annotations and annotation processing were introduced, just to have like a consistent API for that, and not to rely on some hacks and workarounds. Yeah.
Okay, so one request to our audience: if you have any questions, you can add them in comments. And in the meantime, we have also a question from Michał Błahut. It's a bit not connected with the presentation title, but I think it's a really nice topic, and we can discuss about it. So, in the times of hybrid mobile applications that are cheaper to create, is it still a good idea to start mobile development learning by learning Kotlin and focus on native app creating? You can start.
Yeah, okay, we can discuss about it. Yeah. From my perspective, yes, it's a good idea. Mostly because Kotlin is a really new and modern language. Like you can start writing in Kotlin right away. You have a lot of documentation, a lot of I don't know, community posts and materials that you can easily obtain on the internet, for example. So Kotlin is not a problem. It's a fun and cool language, and yeah, just do it. But about the part on focusing on native app creating, this is the same answer. Yes, you should. Mostly because hybrid mobile applications are good to things that are not closely connected to the physical device, I would say, to the things that need to be handled natively. First thing that came to my mind, all kinds of sensors, of encryptions, all kinds of connecting with external devices. Those things really differs between platforms. So iOS can and should handle it differently than Android. So making hybrid mobile application will require you to have this code written in native anyway. So you will need to hire or get help from someone who is experienced in creating mobile applications natively. So it's not like we can create everything in hybrid. We can create many things, but there will be still need for native developers. I think always there will be need for them. Yeah.
Yeah, I have some experience with Flutter, and I really like this technology, and I still think that first of all, the native experience is really important there. Like Gab said, there are always in every application or project there are always situations that you need to touch some native code, and it's easier to do it when you have some in general mobile experience. What I would like to also said is that it's cheaper, of course, from the business perspective. It's really good, and I really think that it's a really good option to do application in React Native or Flutter. But from the developer's perspective, it doesn't mean that when you learn Kotlin you lose something. It's like this is great. This is the great language that we can use also in, for example, Kotlin multi-platform project. I know that it's not so popular like hybrid mobile applications like Flutter or React Native, but it's also developing and really gains its publicity. So I believe Kotlin is a good point to start. You can also write backend in Kotlin, so it's like a lot of
multi-purpose.
Yeah, it's exactly it's you can write everything in Kotlin actually.
Yeah, I can add one more thing, that even if, like Szymon said, if you are gonna start learning the Kotlin, it's not like you are like committed to it for like 10 years, right? Kotlin is from this modern, I would say, family of languages. It's similar to Swift, for example. So if you want to learn the iOS, then you can just grab some tutorial for Swift, and knowing Kotlin, it will be really easy to have a smooth transition to the iOS world. So it's nothing like you are losing something, right? It's more like gaining only, because you will be familiar with modern languages, and that's the main point of it. Like,
yeah, like any language you can start because if you are at the beginning of your career, you can start with whatever language you can. It's like if you start with Java, it's okay. It's an object-oriented language, and it's like always good to learn. I think this is the main
yeah
thing.
Here in Netguru we have like teams, native teams, hybrid teams. We have React Native, we have Flutter, we have iOS, we have Android. So yeah, and everyone from this stack has some projects. So it's not like it's not like having I don't know, only clients which want to have application created in React Native or Flutter. That means that we can easily, and we are doing this often, we can easily recommend in which stack we want to, for example, create this application. For me, I often recommend like hybrid application to clients which needs to have application created in a short period of time, which doesn't look much different on Android and iOS, to have like consistent designs, because React Native or Flutter is great at it. And doesn't touch this hardware side of the phones, for example, because it will be cheaper, faster, and can be done really easily. But if it's some kind of client from fintech, which we have plenty of them right now, then the recommendation is to have a native app, because security is the very important factor of this application, which can be assured only on native platforms. Mostly because, for example, React Native is dependent on its releases, right? For example, when there is some security bug fix on Android, you need to wait a bit to have it implemented in your application because you are dependent on the additional framework, right? So the answer is it depends, right? but it's definitely worth to take care to start working on creating native apps. But feel free to choose anything you want.
Yeah, and also like I have a feeling that sometimes the enterprise companies just want native applications because they know how it works, and they have some teams that are already or some projects that were already developed in native, and they want to stick to it. And it's also something that we need to take into account. Yeah, and by the way, speaking of clients and speaking of different technologies, we have open recruitment to Netguru. So if you want, if you would like to join us, I believe that there in the comments there are some links to our recruitment processes. And yes, we are actually closing to the end of our meeting, and yes. Actually, I want to just thank you to all of you for your participation. Thank you, Gabs, for great presentation and nice discussion. I have also two requests for you. I mean, for our audience. There in the comments, you can see the feedback form. If you like the event or you see anything that we could improve, please fill the form. It's really important for us because we want to do it better. And if you want to know about events like this, you can subscribe for our mailing. I believe that I said it properly because I don't know yet how to do it, but for sure there is also a link that you can subscribe. And of course, follow our social media. You can follow us on LinkedIn, Instagram, Facebook, etc., and a lot of good stuff you can see there. Okay, so I think that's all. Thank you very much, and see you next time.
Thank you so much. Thanks for having me, and have a nice evening. Thanks.